Welcome to Integrated Math 3. On this episode, Stevenson will demonstrate
Let's look at one other function that we are familiar with, which is the cube function, x to the power of 3. And let's look at its inverse. And let's talk about how it gets modified, if at all, like we did with the square root function. So, first thing I want to do is take my cubic, graph it, and then I'm going to invert the points to create its inverse. But first, I'm going to graph the cubic using these ordered pairs. Now I'm going to do the inverse. Now you may notice the inverse already has that inverse notation. We'll come back to that. But now what I'm going to do is take each of these ordered pairs and switch them. So all of these outputs become the inputs on my inverse, and all of these inputs become the outputs on my inverse. Let's look at our graphs now. We know that c of x, which is x cubed, is 1 to 1, so it is a function. Look at its inverse though. Its inverse is also 1 to 1. That means it is a function. So this is why it already had the inverse notation here. These are invertible. So they both have a 1 to 1 relationship. Let's go ahead and look at their characteristics. The domain of the parent cubic was all real numbers, which means the range of the inverse is also all real numbers. The range of the parent cubic was all real numbers, which means its domain is all real numbers. It went through the origin, so both of its intercepts is the origin, and if I switch those, the same is true on the inverse. So in this particular case, when you look at the cube root function, its characteristics are identical to where it came from, so nothing too exciting here. But this is the parent cube root function now. Parent cube root function looks like that. So both the square root and cube root functions are a part of the radical function family.